Good morning, class. Today we are going to continue with the PLC programming. I will be creating a short program to simulate a non-retentive latch, similar to the using a start-stop push button station to start an electrical motor, and also this process will affect the startup of a second device or a second electrical motor, okay, or a second set of lighting system. So the first thing that I have to do is open the software, the click software. So to open the software, we need to double click on the icon, okay? So I'm right here, yes, click on next and close here. So we are going to start a new project, okay? And right here, this is the number that appeared, that is displayed at the top of the PLC. In this case, this one. Okay, you see it. So we are going to accept, because that is the number that we have, the PLC that we have, okay? And it's a new project. So what we are going to do, similar to the previous one, we are going to create a condition. I click on instruction and then normally open contact, and I will select X2. Don't forget, and then don't forget X2 right here is using the negative logic, which means that if you see open is this one, is closed. Is similar to the start-stop push button. The red one is closed and it's used to stop the electrical motor, okay? So then I will be creating another condition, another normally open condition. So right here I will select a normally open, and keep in mind for the input we are using X, and then my output, in this case, I will go to out. So on the instruction, the third column from the left, at the top, I click on output, click on this menu, and I will be using Y4, which is the blue. But because it's a latch here, I need to create a branch, what is known as a branch. I click on edit, line, okay, and I click on the arrow in the direction in which I want to draw the line. And then when you see the dot, the blue dot, hit escape. And we are going to create a branch here. So I go to instruction again, and on the instruction, I click on normally open. Normally open, and I type Y004. So the output will be controlling this contact, okay? And then on the second run, I will have another condition that will be depending from the first set of instructions. So I will create a normally contact. I will include a normally contact, and this will be X2, similar to the push button station, start, push button station. And then I will have this one depending from Y004. So I will create I insert a normally open condition right here. Sorry. So I can type here Y004, and then I have my own set of conditions. I will include another normally open X3. And the output will be output. Y002, and Y002 will be used as a latch, okay? So I need to create, I go to edit, line, and right here I click on the line, and then right here, and I will insert another instruction, normally open, the same. So I will type the latch Y002. Okay, now I need to, let me explain you this before I transfer into the PLC. Okay, hardware. So these are closed. Even though you see it open here, they are X2 at the hardware level is using the negative logic, which means it's similar to the stop, start, push button. The red one is closed. Okay, the green one is open. Okay, so this is closed, even though you see it open here. Okay, so when you press down X001, so you will have an output. This output will be energizing or closing this. When this is true, this will be true as well. And immediately this is true, this becomes true, and because this is closed and this is closed, it's waiting that you press X3. If you press X3, you will have an output here, and this output will enabling Y002 will be closing this and holding this. So in sequential, the sequential process is this. This has to be through or energized in order to have the second run, okay, through this Y004. So writing this into PLC means that what you have on the screen will be converted into the PLC click machine language. That process is known as a compiling. Compiling a software means that what you have at the software level that you could, as a human being, could understand, will be converted into the CPU machine language, which is unique, okay, for the click PLC. And I do this clicking on PLC, writing this program into the PLC. Let's do this. So I click on PLC, then write project into the PLC. It's connected using a communication port COM4, connect. There is a mistake here. I need to include an N. Right here, I need to tell the software where my set of instruction is N. So I need to include an N here. Okay, now I should be able to go back PLC, write the project into the PLC, save it as a new project 93. It will be turned the PLC hardware into a stop mode. Then it's asking me to go back to run. And look, so you see the alpha color is telling you that you have energy at the software level. So if I close X1, I will be closing X1. It's ready. We have output on Y004, Look at the blue, it's lighting up. Then if I press X3, the red one goes on, lighting up. If I want to stop both of them, it's a sequential. So the first one should be a start, the first one should be off to open and de-energize the second output. One more time. Okay, so in this case, look, if I press X1, we have, right now, what we have is Y004 true or energized. This is closed. I told you X002 is using negative logic, which means that when you see open here, in reality at the hardware level, and when you start using the program, it's closed. So I already pressed 001, X001, Y004 is true. This is holding or latching this, and then this one energize this. Just is waiting to have an output on Y002. I need to press X003 right here. If I press X003, I have an output. If I want to stop, so X2 will stop both of them. Okay. So this is another example of using PLC software. In this case, the objective is to create okay, a sequential start. This has to start, and then the second will start. The second round, the second set of instructions depend from the first round of instruction. Okay, keep in mind, this is the instruction, and this is the condition area, and this is the output area. Okay, guys, that is what I have for today on this lab. Good afternoon or good morning. Okay, see you the next